All right, basic algebra D, here we are for 14.2. We are going to be taking what we learned about finding the vertex, both points of the vertex from standard form, and we are going to now use those points to graph. I'm going to be doing some things in terms of organizing my work. All of the work that I'm going to do to find my vertex, I'm going to put in this space here. All of the work that I'm going to do to find additional points, I'm going to do in this space over here. So bear with me while I kind of figure out the most efficient way to do this. When we're working with our vertex, we know that we're going to have v equals sum two numbers. We know that we have to do negative b over 2 times a, and that we are going to take whatever number that is and plug it in for x. We're going to replace x with it. So if you notice what I did here, this that I'm highlighting in red is my rewritten equation up here, just without x's. Instead, I've replaced them with parentheses. So this is what we did in 14.1. We're saying the opposite of our b term. So remember our b term, we have a, b, and c. So a is 1, b is 2, and c is negative 3. So the opposite of our b term, the opposite of 2, is negative 2 over 2 times our a term, which is 1. Because that's a 1x squared. Okay, so as I evaluate this out, excuse me, we have negative 2 over 2 times 1, which is 2. And when we work that out, we get a negative 1. Negative 2 divided by 2 is negative 1. So the first point in my vertex is negative 1. We are going to use that and plug it in here. This is everything we worked on in 14.1. So we have y equals negative 1 to the second power is a positive 1. I'm going through the order of operations. Now I'm going to multiply. So 2 times negative 1 is negative 2. So y equals 1 minus 2 minus 3. And then I'm putting these together. So 1 minus 2 is negative 1. Minus 3 is negative 4. So when we plug in a negative 1, we get out a negative 4. All right. That's what we worked on last time. We are going to use our vertex. So our vertex, if I were to graph it, it would be negative 1, negative 4. It would be this point right here. Something special about our vertex is, I'm just going to kind of fake draw in a parabola. Whatever our parabola is, it's going to switch, it's going to bounce, it's going to switch through the vertex. So whatever it's doing on this side is being mirrored over on this side. So we're going to create a table and use some different points based on our vertex. So our vertex, if that's the middle point in our parabola, it's going to be the middle point in our table. And I'm going to do the work for the table down in this space in terms of filling things out. So we are going to have x, and we are going to have y. And then the middle point, our vertex, is negative 1. So I'm going to use that as my middle point, and then I'm going to pick 2 points smaller and 2 points larger. Remember, on a number line, negative 2 and negative 3 are actually, they're to the left of negative 1. They're smaller than negative 1. And we know that our vertex is negative 4. So if it helps, I can create some lines here just to kind of help keep our work organized. And here's what we're going to do. Just like we did up here, where we replaced negative 1 for x and then figured out what we would get for y, we're going to do the same thing for each one of these points. Now, we're not going to do it 4 times. We are going to do it only twice. We're going to do it for either of the numbers that are 1 away and either of the numbers that are 2 away. Because our axis of symmetry and our vertex is that switch point, whatever we get for 1 away on this side, we're going to get 1 away on the other side. So you'll see how that works out. So here's what we're going to do. And again, I'm just kind of trying to figure out how to explain this the best. We are replacing x with some value. So here's my original equation up top, kind of like we used. And I'm going to replace it. I'll use blue so that you can see the difference. I'm going to replace it here because 0 should be pretty easy to plug in. Oh, I was thinking of 0. And I'm also going to replace it down here because 1 should be pretty easy to plug in. And I'll use purple for that one. So now it's really important that as we're doing this, we go back and just double check to make sure we've copied things down correctly. So x squared, so blank squared, plus 2x, so plus 2 times blank, minus 3. So we're looking good. And here's the deal. Whatever I get for my blue here is going to be reflected across and we'll end up having the same point there. Whatever I get for my purple here is going to be reflected across and I'm going to get the same point there. So we really only have to plug in 2 equations instead of 3. So we're saying if x was 0, what is y? So if I were to evaluate this, 0 squared is 0, plus 2 times 0, which is 0, minus 3. So 0 plus 0 minus 3 gets us a negative 3. If we were to plug in a 1, and a 1, we would have 1 squared, which is 1, plus 2 times 1, which is 2, minus 3. And if you were doing this on your own, you'd want to do this on scratch paper or maybe line things out to write out all of the work. So 1 plus 2 is 3, minus 3 is 0. So when I plugged in a 1, I got out a 0. And we can reflect across to match those sides. And I'll kind of show you as we graph it as well. So we're going to take a look at our graph here. I have my vertex point down. I'll use blue for 0, negative 3. So if I go 0 left and right, down 3, I'm going to land right here at negative 3. And if I go, so I was looking at this one. So that was 0, negative 3. So if I look here, I have 1, 0 in purple. 1, 0. So that's that point there in purple. And remember, our axis of symmetry cuts through our vertex. So I can reflect, I can count 1, 2. If I go 1, 2, I end up with a blue point there. And if you notice, these coordinates, -2, comma, -3, are the same coordinates we have here. So we can either count and reflect, or you can just plot the points. So I'm just going to plot -3, 0. If I go -3, 1, 2, oh, I'm sorry, these are counting by doubles. 1, 2, 3, and 0 is going to be that point there. And you should notice that if we were to reflect, it does reflect. If I were to go 1, 2, 3, oh, sorry, I counted to the y-intercept. 1, 2, I can go 1, 2, just like that. 1, 2, 1, 2. I know it looks a little bit crazy. We're going to keep practicing this. But that's our parabola. So even though there are kind of a lot of points, we only had to plug in for 3 of them. We plugged in to figure out our vertex, and then we plugged in 2 other points. And we could have picked these 2. We would have gotten the same numbers out. So let's try it again on number 2. Okay, so the first thing I'm going to find is my vertex, and that's by using -b over 2a. And if I plug that in, I have my a, b, and c here. The opposite of b, so the opposite of -6, which is +6, over 2 times 1. So that gives me 6 over 2, which gives me 3. So in my vertex, my first point is 3, and then to find my second point, we're plugging in, we're saying y equals some number squared minus 6 times a number plus 5, and that number that we're using is 3. So we'll evaluate. Y equals 3 times 3, which is 9, and then a -6 times 3, which is a -18, plus 5. And as we evaluate this, 9 minus 18 is -9 plus 5, and -9 plus 5 is a -4. So when we plugged in a 3, we got out a -4. That's our vertex. So our vertex, which I'm going to do in red, is +3. So we're looking at +3, comma, -4. So I'm going down 4 right here on that spot. Our axis of symmetry cuts through our vertex. So that's the switch point there. All right, so from here, now we are going to find 2 points and reflect those points. We can reflect them on the table. We'll also reflect them on the graph, where you'll see that they are reflected on the graph. I'm going to try organizing my work a little bit different this time. I still know that I'm going to need to use an XY table. I still know that 3 is my middle point and -4. Oh, didn't like that. And I'm going to use the 2 smaller, so 3, 2, 1, and 2 bigger, 3, 4, and 5. And I'm going to use 1 and 2 for these. So I'm going to use 1 in purple, which will correspond with my 5. And I'm going to use 2 in red, which corresponds with my 4. I'm sorry, in red, in blue. I was thinking about how, since I used red on my vertex, I'll make that red to correspond. Okay, so I'm going to try organizing this a little bit different. I'm going to take 2 different spots here. I'm going to do some work right here, and I'm going to do some work right here. How you see fit to organize it, it's up to you. And we're saying y equals some number squared. So remember, we're just replacing the x, minus 6 times a number plus 5. And we're doing the same thing over here. Y equals some number squared minus 6 times some number plus 5. Okay, and the numbers in blue, I'm going to use 2. So I'm going to put a 2 here and a 2 here. I guess that's a lot of blue. And then in purple, I'm going to put a 1 and a 1. So I'm not mixing and matching. I'm not using 1 and 5. I'm not using 2 and 4. Whatever I get for this 2, I get to plug in for this 4 as well. Whatever I get for this 1, I get to use for that 5 as well. But we're not mixing and matching in the equation. We're just using 2 and 1. So I'm going to solve this first one out. 2 to the second power is 4. Negative 6 times 2 is negative 12 plus 5. 4 minus 12 is negative 8 plus 5. And negative 8 plus 5 is negative 3. So when I plugged in a 2, I got out a negative 3, and that works for both of those. When I solve for 1, 1 squared is 1, minus 6 times 1, which is a negative 6, plus 5. 1 minus 6 is negative 5 plus 5. And negative 5 plus 5 is 0. So when I plugged in a 1, I got out a 0, and that would be true of both of those. So now all we have to do is plot these points. So in blue, I'm plotting 2, negative 3, 1, 2, down 3. I can also plot 4, negative 3, and if you notice, they do reflect. I can count the same amount to each. That's why we don't have to do 4 problems of math, just 2. And then with 1, 0, which is right here, and then 5, 0, which is right here, and again, they reflect. I can go 1, 2, 1, 2. And so that creates our parabola there, even though I totally missed those points when I drew it. A little bit harder on the tablet. Okay, we're going to do 2 more, and that's it. So I'm going to talk a little bit less through these and just solve them. And then we'll go from there. All right. Negative b over 2a. The opposite of our b value is positive 16. So the opposite of b over 2 times a, which is negative 2. That's 16 over negative 4. And that means 16 divided by negative 4, which gives us a negative 4. So my first point in my vertex is a negative 4. To go back and find my second point, I'm going to replace it, let's use red, with negative 4. All right, so hang with me here. I'm squaring it first. Negative 4 to the second power is positive 16. If I work these out, that's going to give me positive 64 minus 30. Negative 2 times 16 is negative 32 plus 64 minus 30. If I put these two together, you'll get positive 32 minus 30. And 32 minus 30 is 2. So there's my vertex. Negative 4, 2. I'm going to plot it in red. Negative 4, positive 2. And our vertex is all the way up here. If we look out front right here, this is telling us, will our parabola open up or down? based on this negative. Will our parabola open up or down? Yes, you should have said down. All right. Here's my XY table. I really preferred, so I'm going to use two numbers smaller, -5, -6, and two numbers larger, -3, -2. I really preferred doing my work in two separate little spaces, so I'm going to continue to do it that way. We're saying y equals -2 times a number squared minus 16 times a number minus 30. And I'm doing the same thing over on this side. Okay. And again, whatever I get for, if I use a -6 or a -2, I get the same output. Whatever I use with a -5 or a -3, I'm going to get the same output. And again, we did the vertex in red already. And part of that is because our axis of symmetry, right, those points are going to be reflected. So 1 away is going to reflect with 1 away, 2 away is going to reflect with 2 away. I'm going to use -3 and -2 just because they're smaller than 5 and 6 in terms of absolute value. It should be a little bit simpler to work out. So plugging in a -3 here, I'm going to evaluate. Okay, order of operations means that I have to work out this, -3 to the second power, which is a +9. I'm going to go through and do all my multiplying. That's -18. And let's see, this should be +48. And then -30. And then as I go through, 48 minus 18 should give me 30 minus 30. So y equals 0. Yes, all that work just to get a 0. So when I plugged in a -3, I got out a 0. All right, my purple, I'm going to use -2. Y equals -2 times, we're going to square this, so -2 times -2 is +4. I'm going to multiply these out, so that gives me -8. That gives me +32. And now I'm going to work these out. So I can do 32 minus 8 to get 24. And 24 minus 30 is -6. So when I plugged in a -2, I got a -6. If I plugged in a -6, I would also get a -6. So now the last part's to just plot these. So I'm going -5, 0, which would be right here, and -3, 0, which would be right here. I'm going -2, -6, all the way down here, and -6, -6. And you can tell they do kind of reflect across, not kind of, they do reflect across to each other. So that's our parabola. All right, last one, and then we'll be finished for today. So, nice simple one. First step, find the vertex. So, V equals, in order to find that, I have to use -b/2 times A. My A, B, and C, so my B is -6, so the opposite of -6 is +6 over 2 times 1. which gives us 6 over 2, which gives us 3. So my first point's 3, which means now I know what I can plug in for x. I can plug in a 3. Three squared is 9. Negative 6 times 3 is negative 18. 9 minus 18 is negative 9 plus 8. And negative 9 plus 8 is a negative 1. So when I plugged in a 3, I got out a negative 1. I'm going to plot that in red. 3, negative 1. And having that point down there makes sense because this should open up because it's positive. There's my axis of symmetry. Now we're going to make a table, x and y. And I know my middle point is 3 and negative 1, so I have to figure out one away, and one away there, one away there. So 2 and 1, 4 and 5. Think of a number line, right? And I'm going to organize my work again in these boxes. I think I like this much better than writing it linear, just because it gives me space to work. So y equals some number squared minus 6 times some number plus 8. Same thing. And then we're plugging in. So I'm going to use, for my first one, I'm going to use my blues. For my second one, purples. And I'm not mixing and matching. So I can use either my 2 or my 4. I can either plug in a 2 or a 4. In this case, I'm going to use 2. I like to go for the smaller numbers. And then for this one, I can either use a 1 or a 5. I'm going to use 1. If you're feeling brave, go for it. 2 squared is 4, minus 6 times 2 plus 8. Negative 6 times 2 is negative 12. 4 minus 12 is negative 8. And negative 8 plus 8 is 0. So when I plugged in a 2, I got out a 0. And if I would have plugged in a 4, I would have also gotten out a 0. All right, and then I'm doing 1 squared, which is 1, minus 6 times 1 plus 8. Negative 6 times 1 is a negative 6. 1 minus 6 is negative 5 plus 8. And negative 5 plus 8 is 3. Okay, so now I just have to plot my blue points, 2, 0, 4, 0, and see how they reflect. And then 1, 3, which would be all the way, let me use purple, all the way up here, and 5, 3, which is all the way up here. Okay? So just a quick recap. In order to graph these using a table, we find the vertex first by using negative b over 2a and solving, getting our number and then plugging in and solving to get our vertex. Our vertex is the switch point in our graph, and the first part of our vertex, the x value of our vertex, is our axis of symmetry. So it cuts through 3. Then we use that to create a table. 2 numbers smaller, 2 numbers bigger, and then we plug in just one of those sets. solve, and then it reflects. All right, hope you all are well, and we will continue graphing and looking at some different ways to find information from standard form, as well as using vertex form in 14.3.